Hello, I'm Terry, co-founder of Remix AI, and today I'm going to chat with you a little bit about what we've been doing fine-tuning language models to use tools. So large language models, or LLMs, they're good at next token prediction, but that leaves them prone to making mistakes or what people call hallucinating. What we need is to figure out how can we trust code execution coming from an LLM. And one technique that's working pretty well is to develop an agent which uses tools. So what's an agent? An agent is an LLM that's essentially prompted to take on a role, and it turns out you can build like more narrowly defined specialized tools so that you can associate an action, maybe it's a verb or a high level vaguely specified user intent with a particular tool that you want to use. LLMs are good at inferring the correct input, and if you design a tool well enough, it's pretty simple to match that user intent with the specific tool. So that when you're having a chat UI for some technical workflow, you can pretty reliably match that to what you really need to do in terms of the detailed code execution that's involved. If you've tried using tools like Gorilla CLI, you can often get stuff that's pretty close, and it might help you to find what you really want to do running FFmpeg in the terminal, for example. But there are times where it's not quite right, and so building a specific tool for a workflow that you're going to use a lot and building this into an agent that can use it means that it's easy to iterate and compose these tools to build out more complex workflows. So here we're scrolling through Hugging Face's documentation on agents with tools, and you see that they have example tools like text-to-speech, where a user might be able then through a chat UI to specify in a very high-level way what they want done and whatever information might be necessary, input information for the tools. Then the agent has an awareness of what the tool's methods are, basically by how it's described, how you named it, what the doc string associated with that tool says about its intended use. The input information can be inferred by the LLM, and then the agent can be prompted to select the tool and run it. So here's a bit of Hugging Face's documentation on using custom tools, and you see that they have this description, the doc string for the tool that has a name. So we started thinking about tools that would be beneficial to us, and we're often making instructional content around using our engine for making ML models. So it seemed like a useful opportunity for dogfooding, for us to take a lot of the common things we might be doing with a tool like FFmpeg and creating a chat UI to make that very streamlined. Maybe I want to be able to describe a style of video editing that I want done. So we got to work wrapping FFmpeg through FFmpeg Python bindings, and we host a model remotely. It's trained on Code Alpaca 20K. This is good for code generation in general, which makes it good for instruction following, and ultimately it makes it a good starting point for us to map user intent to tools. And that's what they show how to do in their documentation. And as we were building out a suite of tools in FFMPerative, we found that we wanted to push the limits of the workflows that we could compose with these tools. And one idea that became important to us is that we fine-tune our own LLM so that we could run it locally. We wouldn't require using the StarCoder model, the remotely hosted model by Hugging Face, and we might even be able to specialize the model to have an awareness of the tools that we use, and then associate some of the common ways a user might express their intended workflow, associate that with the tool more directly to optimize the LLM for using our tools. Hugging Face has provided the local agent, so you can take a checkpoint of StarCoder, which they host, and pull it down, and you won't need an internet connection, or you might use another LLM, like we're describing one that we'd like to fine-tune. And at first we thought we would fine-tuned starcoder, but we did find it's pretty resource intensive to do so. You need a couple A100s. But recently, Meta's released the LlaMA 2, which is commercially available too, and includes a 4K context window, which was important. We found that when we add in all of this description information of all the tools in FFMperative, that we're just over the 2K token limit. So we wanted a 4 or 8K. Recent progress around expanding the context through rescaling the positional encoding information is made it easy for people to take a model that was trained on 2K context window, but then fine tune it and adapt it for larger context. And that's been really powerful for using with tools where you want to create a prompt that includes a lot of information about all the tools and how you might use them. And when we're using LlaMA, we can also benefit from LlaMA CPP, a very popular code base for running these LlaMA models in C. And we can optimize these models with 4-bit quantization. And so as we were thinking of ways that we could specialize our LlaMA 2 to use our tools, we turned to ChatGPT, GPT-4, to create a bunch of training instances. And the idea here is to take a typical user intent, like if you were using chat for FFmpeg, you might simply want to describe in a high-level way, like rotations or transformations, effects that you might apply to the multimedia content you're trying to edit. And then the answer that should be associated with that should be using the tools that we've created. So we pasted all of this context into GPT-4 and had it construct a bunch of these question-answer pairs. We could try it in different languages to keep it robust and not overfitting to a specific phrasing. And we also wanted to experiment with greater composition before, like trying to edit for dramatic effect. And we see that GPT-4 has enough context to make recommendations about the kinds of visuals or effects that you might want to pull off a certain aesthetic. So we added hundreds of instances like this that we had generated with GPT-4 to a subset of the code alpaca 20K that starcoder was trained on. And we fine-tuned our LlaMA 2 on that data set, which we've hosted here. On Hugging Face, you can see a bunch of the training instances that I was describing before from ChatGPT. And we trained our LlaMA 2 model on it. The script that we used is in here. It's using parameter-efficient fine-tuning methods. So that's a convenient way for just making an adjustment to a relatively very small number of model parameters while freezing the majority of the network. It makes it easy to train on consumer-grade hardware. We didn't need the A100. We were training on our Titan RTX. And it was fast to do. It took only a few hours. So once we've trained that, we can run it locally, and we've got a bit of that sample code here that's using the local agent, which means that you can use FFmperative and download the model that we've shown here in this card. The LlaMA 2 7B is fine-tuned on the FFmperative data set, so that it's got awareness of the tools that we want to use for FFmperative, which means that instead of using the remote server, you can keep everything local and do video edits locally using chat with FFmperative. So we wanted to see how far we could go in composing FFmperative calls and seeing to what extent we can edit video and make complex sequences. And we found that by bringing in a couple of other LLMs like Vicuña through Video LlaMA and GPT-4, we would be able to get information, contextual information through video understanding with Video LlaMA, construct a prompt with all of this context that we send to very powerful models like GPT-4, prompting it to act as an editor and construct a sequence of edits that would be appropriate for the type of video we're trying to make. And that edit plan comes down locally where we're running FFMPerative, and we have awareness of these tools then to perform the edits and combine the sequence together. And so that's how we made some of these video sequences that are shown in this Reddit thread, project we call B-roll. Through that project, we were working more with the idea of using multiple agents, and it's got the advantage that each can be specialized to a specific set of tools or take on a particular hat for the task at hand, that communicate through high-level English directives. It's very interpretable, provides the observability that you might want as you're trying to work with a complicated system, and it can help you determine like which agent or which prompt needs more refinement to get the effect you're looking for. And so as we're thinking about other technical complex workflows that we might want to be able to simplify through a high-level chat UI, we're thinking about things like capture the flag challenges or pen testing workflows, where depending on whether you're interested in inspecting network traffic, if you want to reverse engineer a binary, if you're solving some cryptographic challenge, there's many different tools that you might be using, not just one complicated tool like FFmpeg. We started to use GPT-4 to explore how we could develop a suite of tools for pen testing workflows and capture the flag, call it CTF Copilot. We learned about how you might want to design an agent that can consume information from a threat intelligence feed and then be taking actions on behalf of the network admin to adjust firewall rules depending on what information is coming from. So what will you make? We're working on a whole set of tools that we want to use to simplify the complexities of ML ops and developing custom AI applications at Remix. So feel free to subscribe to our newsletter for this channel and stay tuned for the tools that we're going to be releasing at Remix to help simplify machine learning workflows. This is Terry at Remix signing off with a reminder to think globally but LlaMA locally.